said that earlier. You said that, right? So, how many of you knew that when you are driving a car or when sitting in a car, the efficiency of transporting you from point A to point B is only 3%. That means 97% is lost. Where does it go, that 97%? Into the? Sorry? Yeah, please. Environment is not useful. And yet, every day, how many thousands of cars are coming on the road? New cars. So if you want to have innovation, isn't it a good place to start with? And you can see the whole picture. Where is the maximum loss? The engine itself and standby loss. If the total loss is this much, this is already a big chunk of that. More than 75% is lost in the conversion of chemical energy of the fuel to mechanical energy. So when you're talking about green energy, it's not just solar, etc. If you are getting clean energy from sun, but only 3% is used, 97% is lost. Is it so green? So we need to also think about not how we get the energy, but how we use the energy. Okay? So my first action today, I didn't do anything so far. If you open the curtain now, do we need all the light? So let's start with that. These rays. Go and open the curtains and we'll switch off the light. We have to think about why did we make glass? To get the daylight. Now you can switch off the light, it will be alright. Okay, when I switch off, what happens? That side is okay, this side is not alright. Right? When I switch off, that side you can get light. Today it's not very sunny, but enough for them to read and write because we don't need to have so bright light. Here it may not be enough. What do you find? What is wrong with the switch? The switch is designed in such a manner that it takes the whole row. Whereas there should have been separate switch this side, separate switch that side. Because this side switch can be switched off when there is enough daylight. So you can see innovation is not just new things only, also how you design things. That things work better and you reduce the efficiency. Losses, wherever there are losses. Okay. So we can think about all aspects. Now look at it. Look in the room behind. Anybody sitting? With the lights are on. So you start looking at it because you can laugh at it. But in reality, that is how much of the energy is lost where it's not doing anything good for us. We don't realize it. You go to many places, whole night the light is on, but people may use it only for half an hour. You go to many public toilets, the lights are on, the fans are on all the time. So innovation would be to get the right type of sensors, because people may not switch off always. You get the right type of sensor by which, when you don't need it, automatically it will switch off. When you need it, when you walk into a place, it will light up. And that's where, again, that's green energy, because it's not just about the source of energy, how best you make use of it. What helps you to make it more efficient? Okay. So when you talk about green energy, it's not just about solar, wind, etc. You have to look at the whole system. So you can see how inefficient our system is. And more people, all of you, when you grow up, everybody wants to have a car. Yeah. Right? And this is the system that you would like to have. Is it the way you should go about it? Now, next step. What can you do? Today, what is the innovation that we're talking about? What is the innovation we're talking about in the vehicle? Yes? Electric vehicle. What is the improvement compared to this one? This is efficiency we saw is 3%. Now if you go for electric vehicle, where is the electricity coming from? From the power plant. Power plant may be using coal, oil or natural gas. Okay, so now we get a new balance. Road resistance has not changed because you want to move from point A to point B. It's the same output. Output is the same, 160 kilojoule. But what has changed? Drag has not changed because the design of the car has not changed. But no engine here. The biggest loss in a petrol or gasoline engine was the engine loss. Efficiency is 25% or less. Here you have an electric motor. Electric motor efficiency is 90% or more. So you can see the motor and braking losses become very, very small. Electric vehicles have batteries. So batteries also have some losses. The batteries use a charger to charge the electricity from home. That has some losses. And then electricity is supplied from a power plant which is far away from your home. So there is some distribution losses. And in the power plant there is some loss because the power plant is not 100% efficient. You have loss in the power plant. If you look at the whole picture here, in the previous one, the biggest loss was in the engine. But that engine is now in the power plant. So the loss has shifted. But if you do the balance now, how much is the energy which is supplied in the form of coal? Energy which is supplied. This is the energy which is supplied, the total amount of energy which is supplied. Energy supplied here, only small quantities remaining for the vehicle. What is the efficiency of an electric vehicle which is charged by grid electricity? Oh, very good. You have done your homework already. Very good. So, what did you find? What is the difference between this vehicle and the other vehicle? The other vehicle efficiency was 3%. This one is more than 12%. So, what is the difference? That means you can get 4 times more output with the same amount of energy. Minimum 4 times. So we achieve what is known as a factor 4. That means we can get the same output, we don't sacrifice, we travel the same distance, but we consume 4 times less input. So we achieve a factor 4, we divide our consumption by 4 times. Even if the population grows, doesn't matter. Even if no more vehicles come, doesn't matter because we have divided our consumption 4 times by switching from normal gasoline vehicles to electric vehicles which are running with grid power. We can go a step further. Why should we go to a power plant? Why should we go to a power plant? We can do it with some other sources. Can you think about any other source? Renewable energy source, solar energy, wind turbine, others. They will not have such big losses and they don't require any fossil fuel. We'll see the balance of what happens with that. You can see already we go from 4,800 to 1,200, a factor 4. We have reduced 4 times. We go a step further. Now we use solar panel here. Okay. Same amount of energy required to move the vehicle, same amount of drag, same amount of motor losses. But you can see there is no more losses in the power plant that we have. Because the energy is from the sun's light, which is converted into electricity. That electricity is going to charge the battery, so there are no transmission distribution losses. Wherever you produce it, you use it there. Right? How much is the energy now required? 362. What is the efficiency of this system? 44%. So you go from 3 to 44%. How many times? A lot is how much? We have our calculator. Huh? Almost 15 times, 14 times, 14, little over 14 times. So imagine this is where is what we call dramatic change in efficiency improvement. That means you can do the same distance traveled with 15 times less. That means if 15 more vehicles came in, you'll be consuming the same amount. But of course, we have to reduce it because we know there is a problem. We have overconsumed and we are creating global warming and climate change. So if you bring in the right technology and use it, we have a solution here. So I just give you one example of transportation, what can be done. Do you understand this example? So if you want to talk about innovation, we don't want to make small steps. We want to make drastic changes where we can achieve this type of factor 15, factor 14. 14 times more efficient. That is 14 times less need for resources, whether it's energy, whether it's water, whether it's raw material, etc. So this is green energy. Green energy is not just renewable energy. Okay? So you can see here, when the electric vehicle is used with solar light, efficiency increases to 14 times more efficiency. So now we understand what we use is not what we need. We use so much, but we don't need that much. We need only this much. Right? But because our system is not the right one, see it. I would like to show you something. This is at my home. Now it is producing 2.04 kilowatt. We can take it up a little bit so that we can see the graph. Yes. Bring it down. Bring it down. Thank you. So you can see here, this is monitoring the electricity consumption in my home, which is in India. This real-time basis I'm seeing now. And you can see the curve since the morning. Of course, there's a time difference because there's 1.5 hours time difference. So the green one is solar. It starts producing electricity at about 7 o'clock in the morning. But it shows here 8 something because there is 1.5 time difference. Now it is producing about 2 kilowatt. The red one is the use, but actually there is no use now because hardly any use is there. So all this is sent back to the grid. So somebody else is benefiting from this solar because we don't have any need. You can see, I can see all the appliances when the microwave is run here. Sitting here, I can know when the microwave is switched on. And we try to charge the car only during this period when there is sun available. So you can see it's possible to achieve 14 times. Technology is already there. It's a question of innovation is not just in terms of technology. How do you innovate in the society? That people think in a different manner. How do you make it more affordable so that people will go for electric car and not the gasoline car? How do you make sure that on top of the roof you use solar panels? So if it's put on top of our roof, the roof is protecting, the solar panels are protecting the roof, so heat is not coming down. So building is cooled. So you don't require to have so much of cooling. Okay? So when you talk about green energy, there are solutions which are very simple, but we have to package them. It's not just about some great innovation, but many small components. This is a systems approach. many small components, when you put them together, you can come up with solutions which are 10, 15, 20 times more efficient than the normal one. And unless we find similar solutions in our life today, whether it is use of production of food, whether it is water, whether it is transportation, whether it is any other field, we will face a similar type of problem. We have time. Sorry, I'm making because I'm ignorant about how to use it. My story is not over. I'll go a step further to explain to you. Next step. This is what we saw here. And we saw for each of the cases, road resistance is 160 kilojoules per kilometer. Right? Now, we can think, when you use a car to transport us from a point A to point B, what percent of energy in the fuel is actually used to take us there? You go in a car, right? So you drive a car. You go in a car, you drive a car. So the car consumes 160 kilojoules per kilometer. What is the weight of the car? Do you know? Typically, what is the weight of a car like this? What is the weight of a car? Not efficiency of the car we saw was only about very small, 3%. And what is the weight of a car? Any idea? Maybe 1,200 to 2,000. Average, let's say 1,500 kilograms. What is the weight of the driver? What is your weight? Sorry, I hope nobody might not. You know your weight, right? You have been weighing yourself, right? What is the normal human weight average? 65, 70 kilograms, let's say, or less, even ladies. So let's say 60 kilo. 60 kilogram person sitting in a car. The car weight is 1,500 kilograms. So the vehicle is carrying home the vehicle itself or the people. If you have 4 people sitting, 4 into 6, 240 kilograms. The car weight is 1,500 kilograms. So we have to think about it in a different way now. Do you understand what I mean? Okay. So who is carrying, you say when my objective is to go from point A to point B. But when I drive a car, I'm actually carrying, the car is consuming more energy than me. Car is consuming 7 times more or 10 times more energy than me because it's a very heavy car. So when you think about that, you need to find new solutions. Do I need to take a car? A bus will not increase the weight by so much, but the bus can carry 50 people. But the bus weight will not become 50 times more. Okay. Now you can see another thing. We said that normal car, road resistance is there. But if you don't go on the road, we go on the rails, what happens? You don't need to have that. Because it will move on the rail. So that friction will become less. So imagine in the city, instead of driving cars, if you had rails. Who is from KL? Kuala Lumpur? Kuala Lumpur, what do you use now? Public transport? Monorail, metro rail, etc. They all go on rails. They're very, very efficient. They can carry many people. They're very, very efficient in terms of energy use. They use electricity, and that electricity can come from clean sources. So it's not just about car. We have to think about why is it that we need a car? We need to be mobile. We want to guarantee mobility. Mobility is not only through the car. Mobility can be through other means. So how do you change the whole system? When I talk about whole system designing, you look at it from a totally different perspective. And Kuala Lumpur, if they didn't have that, I remember Kuala Lumpur 20 years back, they didn't have all these. It was big, chaotic, traffic congestion, air pollution. But today you see Kuala Lumpur is a very nice city. Most people try to use public transport as much as possible to move. Tourists never will take any public transport, private transport. It's much easier for them to go from one point to another faster, don't get caught in the traffic and all the other benefits that we have. So The solution is not just in the technology. I talked about innovation is not just technical innovation, but social innovation, environmental innovation as well. So you need to go further, not only stop here. You have to think in other way. If you did the same thing, the analysis that I have done with you with the car, you could do the same type of analysis for everything that is essential to us. Food, producing food. Today we are talking about how to improve what we call the food miles. I will eat food which is grown within 50 kilometers radius. I will not eat food which comes 5,000 kilometers away. That is going to change. That's also going to help me socially because my farmers will survive. Many of the farmers are threatened today because people don't buy locally. Environmentally is better because I will not be polluting so much to carry things from very far away. So we can think the same way for food, clothing, housing, mobility. All these aspects you can look at. Okay. I will stop here because I would like to leave some time with you. That if you can make smaller groups, you think about it. Just like I showed you the example of the transport sector, what can be done? Think about these 4 items: food, clothing, housing, mobility. Mobility we have already talked about. We can choose about, for example, waste management, solid waste management. Okay, and all of them are linked with water supply, sanitation. Same issue. Okay, I'll just go through the slides because I have many slides. I will not cover them. I just want to show you another example. Do you know this one? This is called an altered nozzle. Same tap, same faucet. You just change the nozzle here. What is the benefit? Do you know? How much? Don't know? Guess, make a wild guess. 50% water. Because when we put water, how much of that water actually touches our hand? We want it to wet our hand. Much of the water does not touch the hand and just goes into the drain. So it becomes like a spray, it wets your surface. Right? This is an invention which was just came out last November. You can go to the YouTube, you can find this company. This is a Danish or Swedish company. And they said, we have this fantastic innovation. Can you support us? Because no bank will give them money. So that's where we come to how do you create that ecosystem for innovation. Today it is possible because the internet is there, it can take from anywhere. I sit here and I looked at it. In Denmark or in Sweden, they want some money to innovate. They have the idea. And I find it's a great idea. They said, can you give us some money? We'll give you the first faucet. So end of January, they will ship me the first faucet that you made because I made a contribution. So like me, there are millions of people who made contribution to create the eco-environment by which innovation would take place. Because we all support this idea. How do you divide our consumption by 90? Only 2% brings down to 100 to 2%. So imagine everybody use that. How much water saving will be there? We hear about not enough water, droughts in many places. We'll eliminate that notion of drought altogether. So these are what we call disruptive innovation, because these innovations are not changing small things. It's a huge change. You can't imagine. It's disruptive. It's not just changing by 1%, 2%, or 5%. The previous one I talked about changing by 14 times. Huge improvement. From 3% efficiency it goes up to 40 something. So these are the disruptive changes that we need to bring in. And this can happen only with your generation. It can happen only if you stop thinking the old way. Okay? Then you will innovate. And keep in mind what I said, always think about the triple bottom line. Any innovation that we do, look at the triple bottom line. With this I will stop, but what I would like you to do is to take up the 4 issues I talked about. It can be food, it can be water, it can be housing, it can be clothes. Okay. So 4 groups, very easy to make one. I'll go 5. This is food. Next 5, water. Next 5, waste, solid waste. And the remaining on clothing. Right? So just thinking about it, how would you think about the changes that are possible to achieve disruptive innovation in all these areas? Like the example I showed you for automobile, for the car. Car is for mobility, but there is other alternatives. All of you get the question all right? So can you please work in small groups and then we'll make a presentation. I'll give you about 20 minutes and we'll make presentation.